Okay, in this video, I want to go back and look at our previous methods that we talked about to solve a system of linear equations, and I want to talk about which method is best. It turns out the answer is none of them and all of them. Each of them is going to be best for certain situations. So let's talk about when each method is best and what are the limitations of each method. So our first method, the one we've seen before of setting two equations equal, this is only useful if we have y equals this and y equals that. If that's not the format, we're going to have to do a lot of effort, spend a lot of time and effort to make it look like that. So it's only useful when both of our equations or all of our equations are in the format y equals something. Let's see, graphing. Graphing is really great for getting an approximation of the answer, but it's not very great for finding the actual answer if the actual answer isn't a whole number. So like if the actual answer is 1.9, is a graph going to be accurate enough for me to find that out? Probably not. So the graph is only useful if the answer ends up being a whole number. And so probably that means that graphing is going to be my last fallback plan, because how do I know ahead of time if the answers are going to be simple numbers? I can't. So I don't think I'm going to graph most equations unless I just want a ballpark. If knowing the answers between 2 and 3 is good enough, great, then I can graph it and get an approximation. Substitution is best when one of the coefficients is 1. And I will say there's never going to be a time where substitution is going to be really tricky or complicated. So it's always a good strategy to use. Another thing I should say, going back to the only setting equations equal, you can always use this. It's just that you might end up spending more effort writing both as y equals this and y equals that. You might be better off just using substitution at that point. Okay, elimination was best when one variable has the same coefficient in two equations. Preferably one positive, one negative, but even if it was just the same, we can subtract equations the same way we can add equations. So maybe let's say it has plus or minus same coefficient in two equations. With that said, elimination is probably out of the four the most complicated to actually run through the steps of. So if you want to just skip elimination as an option, that's okay with me. The reason I went over elimination, the reason elimination does end up being important, is that this is by far the best option when we look at more complicated systems of equations. So we've only looked at equations with two variables and two equations. Elimination is going to be our best option for more than two equations. We would still have the same set of options, the same set of methods. Elimination is going to be the one that's least complicated when you add more equations into the mix. This method is essentially impossible. This method is essentially impossible when you start adding an extra equation. Substitution just gets really annoyingly complicated because there's so many equations in so many different places. Turns out elimination doesn't really change. It's exactly the same. I'm not really going to go into that, but I'm just mentioning that there are reasons why we talk about elimination. Okay, real quick, I wanted to talk briefly about how do we know how many answers there's going to be. If we go through the problem and we get x equals this and y equals that, that means we're going to have a unique solution. That is our unique solution. It's the particular point x and y equals these particular numbers. There should be signs along the way if we're supposed to get no solution or infinitely many solutions. I still started the same way. I still use the same methods. Only if the answer ends up being no solution, the way I'm going to know that is at some point along the way, I'm going to have an equation that looks like 0 equals 2 or like 1 equals 7. And obviously that doesn't make sense. That's never going to be true no matter what x is. And so you would say no solution. So there should be hints along the way that this is something that's impossible. On the other case, if the answer is infinitely many solutions, if you use the same methods that we talked about in the previous videos, you're going to end up with something that looks like this, 5x equals 5x. Okay, I would say true, always true. Or it might end up looking like one of these. You might end up having a number equals a number. If you have two things that are blatantly always going to be true, then that probably is a sign that the answer is there's infinitely many solutions. One thing to be careful of, just because I see 0 equals 0 doesn't mean for sure that there's going to be infinitely many solutions. But if you're doing the method that I talked about, mainly keeping track of your columns and substitution, keeping two equations together when you're doing elimination, then you should see one of these equations pop up along the way, and then that's the point where you say, oh, okay, I'm done. That's 0 equals 0 means, yeah, that's going to happen no matter what x is. 0 equals 2, yeah, that's impossible. That's not going to happen no matter what x is. So just be on the lookout for either weird looking equations or things like 0 equals 0 or x equals x.